I'm Bruno Rodrigues. I'm a project manager and the project coordinator for Fastest by ABI. And I'm here excited to present you the fast track hybrid testing platform for development of battery systems, or as the acronym says, Fastest. This we think it can be a groundbreaking project that can revolutionize the battery industry. Why? Our main goal is to develop and validate a fast tracking testing platform. And this platform will enable to speed up the R&D battery system and try to create more reliable, safer, and longer lasting battery design, sorry. And now, okay, why do we need fastest and why fastest appeared? I think, in our opinion, as a consortium, there are three big challenges for the battery industry right now. That is, the development is too lengthy. Probably, I think this is an average, but it can go by 3 to 5 years to develop a new battery system. And this, in the times that we live nowadays, it's a long time. The other thing is to develop these type of solutions, we need to have a robust testing system and to perform a lot of testings that can be not only time consuming, but also costly to the companies. And in the end, as a big topic around batteries, we have to ensure that our batteries are safe and reliable. With all of this, what are our main objectives is to develop and test a fast tracking hybrid testing platform, to lay down the pathway for results exploitation and simulation, to develop and validate physics-based and data-driven models for simulating and substituting critical physical characterization experiments, to set up a digital twin information management architecture, and to start take and propose efficient DOE strategies. We are going to focus mainly in three objectives that can summarize a little bit what Fastest is aiming to. That is, in the first and biggest one, it's our hybrid testing platform. That is our centerpiece. And this will try to seamlessly integrate virtual and physical testing, which can enable a rapid and comprehensive evaluation of the battery systems. The other one, it's the digital twin architecture that we are trying to compile not only virtual and database, but also the benches and physical benches tests that we are achieving. And in the end, to develop the design of the experiments that optimize this battery testing, that also enable us to efficiently explore a vast parameter space and identifying the ideal combinations, designs, and operating conditions for optimal battery performance. All of these objectives collectively, I think they will contribute to a development of a comprehensive and efficient battery testing ecosystem. Sorry, we are not going so much in detail. I will do a step backward. We are also not so recently born like the previous two projects. We just turned the 1 year, but this is a project that it's difficult to present a result without having the platform already working. We have already some results. We have already the digital twin structure organized. We are starting. We did a very strong work in one thing that normally it's strange, but it's not really explored. That is deontology. Deontology that will categorize every test that we are going to do, all the things that are going to this database that in the end will allow a decision making, not only for the hybrid testing platform, but also for the digital twin that give us that result. Sorry, and impact. What is our focus? These are big numbers. These are our big key impact features. That is, we are trying to improve in less 20% of the operating time, to improve the safety, reliability, and performance of the virtualization ratio in 40%. For this digital twin to be so we can prove that this is robust and it's working well, we establish 3 use cases. One is automotive, the other one is the stationary, and the other one is the off-road or heavy-duty vehicles that are or are in the road or also present in companies to perform heavy-duty jobs. And this will allow in the end for us to demonstrate that development of the battery system with this hybrid testing platform, it works great. And one of the things that we are also trying to do is to improve the computational time. In this situation, 50 milliseconds faster than the usual one. How we are trying to do this? We are running a lot of physical tests, virtual tests, and in the end, with these virtual tests, we are trying to reduce the order that they are going to do and to consume. Sorry, sensitive mouse, and the time consuming that they have. For example, sorry, we can also summarize these in 3 big points. That is, we are going to do advanced modeling with predicting battery lifespan and the behavior with the maximum accuracy possible. We are also going to try to design the safety to achieve the 40% with AI powered, with a tool chain that it will comply with everything that the safety and standards will apply in this situation. And also to try to, like I told just a minute before, we are also trying to tailor the solutions to these 3 use cases, that is the automotive, stationary, and off-road and heavy-duty vehicles. How is this being implemented? I think we have one of the biggest case, and we already talked, it's specification and use case. We had to understand how this is, how they work. They are unique challenges and they present also unique demands for each one of them. And we are trying to address all of them, and we need to identify what are their main specifications so we can have target experimentation and analysis. This was already performed. This was our first work package. It is already finished. And what we are now working, we have the design of experiments and boundary conditions, that it's the DOE. It's being designed and it's trying to tackle what are the best techniques to do some measurements, for example, from SOC to SOH to all of this, because there are several ways to achieve them or to get those results. And with this design, our main goal is to have a compromise between the virtual and the physical, and try to understand in certain point which is the fastest and which is the most accurate. For some cases, this will always rely on the use case and on the specificities of those use cases. And now, then, to achieve this, we have to develop this, or we are doing these 3 packages. That is, we are doing modeling and doing aging, and try to understand how these are, either virtually with P2D models with simulation, but also with test benches. Then we are understanding how this can be integrated and develop the AI power tool chain to integrate these things. And in the end, all of these will go to a digital twin hybrid platform that will compile all the information, and then it will be an interactive process between DOEs, the modeling, the virtual tests, and also the power chain. And this will go around and it will give us, depending on what is the need, it will give us several things. It's a rather complex structure, the digital twin, and we are trying to build the more robust digital twin possible with a hub for communication, and we'll try to have the best latency possible in this situation with a strong database, but also with a very good interaction with the other things, that it will be compiled in an interesting tool that it's the LIM, the laboratory. Sorry, sorry that I forget the name. The laboratory inventory management system that will compile all the virtualization of the tests, and also and will communicate directly with digital twins. And in the end, all of this will give us a hybrid testing platform that will try to push forward and to streamline the R&D for battery development. That is, it will evaluate what will be the best tests and what will be the best situation to do. It give us what is going to be okay. You must go to do a software one, and we can rely on that one, or it's really better to do a physical test because the results are not yet good enough to be reliable. And then we'll also bring the other things together to try to give you like a decision-based software in the end for us to take the best decision and to try to speed up this development. These are our big consortium that it's composed by some big companies like FEV, BMZ, Flash Battery, Comau. Then we have RTOs from around Europe, also universities that are well known in this area. And in the end, we are trying to bring a strong consortium that can deliver this project to a good end. And I think we can make the difference, and we invite you to visit our website, also to visit our LinkedIn and our news that we published.